Today we want to present about our FYP topic, which is develop of live concrete by using fly ash and bottom ash. First of all, let me introduce myself. My name is Lawrence Yu Junhoo with cut matrix 20 DKA 20F1029.
And I'm Bernard LEONG with CAC matrix number 20 DKA 20F1035.
I'm Dayang AFIQAH binti Awang Mahali and my cut matrix number is 20 DKA 20F1023.
Next. And this is our table of content. Next. So for our live concrete is we produce the live concrete by use the reusable material to produce our live concrete. Like we use the bottom ash as partial replacement of fine aggregate and fly ash as partial replacement of cement to make the live concrete to become more effective, eco-friendly, and low cost.
This is our problem statement. First is environment problem, second is healthy problem, and third is price of increasing, cement increasing. For environment problems, coal fire thermal power station pile up a lot of unmanageable postal materials such as fly ash and bottom ash. For healthy problem, we produce this product of innovation due to factor of course high chemical in building maintenance material, and the third one is the increasing in price of for building materials such as cement occur from day by day. This is our objective to produce the lightweight concrete mixed by fixing the amount of water contents, fly ash, cement, size of aggregate, but we varying the amount of bottom ash. The second one is to determine the compressive strength of lightweight concrete, and the third one is to determine the city of lightweight concrete. This is our scope of research. We use to design the lightweight concrete made by the bottom ash and fly ash. Then we use a size of mold that 100 millimeter. Then we produce 15 cubes to conduct the test. Then you use the bottom ash as partial replacement for fine aggregate and determine it at the age of 7 and 28 days. This is our flow chart, and this is our material that we use in the project, that is coarse aggregate, water, sand, fly ash, bottom ash, and cement. For testing on eco-friendly concrete cube, we do for workability that we produce we do slam test to determine the workability for the fresh concrete cube mixings. Then we do dry density test to the concrete of 7 and 28 day dry at ambient temperature, and determine it the mass and the volume after the concrete is dry to calculate dry density. The third one is compressive strength test. We carry out 7 and 28 days and determine the maximum compressive strength of the concrete after the curing process.
Okay, so this is the specification and standards that we're referring. Okay, next. So this is the steps that firstly we receive the chipping stone at the size and 12 mm, and second step is concrete mixing, and third is doing some tests. Next. So we do casting for cubes of CC, country control, and CB0, CB10, CB20, and CB30. CBA is country bottom edge, and there's a sample of cubes of CC and so on. And cubes been demold after 24 hours and dry curing at ambient temperature. Okay. After that, we will wet the cube for the first day and 7 days and 28 days after of dry curing, and we do compressive strength test, and we collect the final data after compressive test has done. Next. Okay, this is our Gantt chart. Okay, next.
And this is the result analysis. And this is the concrete mix design per cube meter that we use. The concrete ratio is 1, 1.5, and 3. So in CC, which is concrete control, we just control the concrete. And in CBA 0 to CBA 20, which is we have add on the 20% the fly ash as partial replacement of cement at 20%, which is we fix it. And then we control in CBA 0, which is concrete bottom edge 0%, 10 is 10%, CBA 20 is 20% of bottom edge that we control it. Next. And then this is the concrete mix design per cube. Just now is per cubic meter. This is per cube. With this table, we can use this table to produce a concrete by it missing. Next. And then in first day, we open the mold. After 7 days, we take 1 cube for each ratio to do the compressive strength test and density test. And in 28 days, we take another 2 cube for each ratio, do the density test and compressive strength test. Next. And this is the result of density test, which is in 28 days. We calculate in average. So in here, we can see that in the density, which is the most higher ones in 28 days, is 2,252. Next. And this is the compressive strength test that we test. Next. And now we can look at in CBA 20, which is we get the higher megapascal for our concrete cube, which is we add on 20% of bottom edge, which is we get the 32.3 megapascal. So compressive strength can be defined as capacity concrete to withstand load before failure. CB20 with 22.3 megapascal has the greater strength developed compared to other concrete cube mix. This series live concrete is suitable for use in design the slab column connection. Next. So, in conclusion, we have achieved the strength and density of the live concrete by adding fly ash and using bottom ash as a partial replacement of fine aggregate. Initially, our target strength was 25 megapascal. Throughout this project, the sample series, which are CBA10, CBA20, and CBA30, are all achieve our target. Okay, thank you. That's all for our final year project.